The theory of tectonics and continental drift started when early cartographers drew the first impressions of the Earth. They noticed a few things that later pointed to the discovery of the continental plates and tectonics. What they noticed was that the coastline of Africa and South America seemed to fit together like a puzzle piece. Other clues were discovered like identical forms on separate continents, separated by large bodies of water. There were discoveries of matching mountain ranges on opposing continents that later matched fossils and confirmed the separation and formation of a supercontinent. The Greek philosopher Thales had a theory that the land floated on water, a theory called Neptunism, which would later be debunked by the grandfather of geology, James Holton. It was not until many centuries later, after the Greeks, that archaeologists were able to really understand what fossils were and how to properly date them. They later learned that fossils were a hardened material started and left behind by an organic matter like bone, and that the material could be dated. In turn, this new technology led to the finite conclusion that the continents had previously been merged together. The geological evidence had been there all along. It was only the factor of time and the advancement of science that enabled philosophers and scientists to confirm what they had been speculating for centuries. The major breakthrough in evidence that South America, India, Antarctica, and Australia were firmly fused together was the discovery of the fossilized jawbone of the mammal-like reptile Listothosaurus. This breakthrough proved of the supercontinent Gondwana. Frank B. Taylor theorized that in the beginning of Earth's history, two separate land masses from opposite sides of the poles moved toward the equator, crashing into one another, thus forming mountain tops. Taylor also theorized that there was an undersea mountain range, later confirmed as a mid-oceanic ridge, which spans north-south approximately midway between South America and Africa. Taylor believed that this mountain range under the sea was the line of rifting between the two continents that came from the opposite ends of Earth. Alfred Wegener, the German meteorologist, was intrigued by the similarities of continental shapes and influenced by Taylor's theories. Wegener published his theory of continental drift in 1915. He believed that 200 million years ago, Earth was an entire mass called Pangaea. This mass slowly drifted apart and was driven by the Earth's core. Wegener's theory was very convincing because the evidence of corresponding coastal margins, mountain ranges, ancient climates, and corresponding rock successions directly supported his theory of continental drift. Wegener still was unclear what drove the plates to move from one large mass to the current configuration. What drove continental drift is still a complicated and not fully understood process. Imagine water boiling in a pot. The water is moved to the edges of the pot, to the top, and pushed back to the bottom in the center. This is a theory of convection, which is what drives the tectonic plates and creates continental drift. The collision of the continents is thought to be driven by the convection currents deep in the mantle of the Earth's crust. Convection is the motion within a fluid medium resulting from a different temperature from top to bottom. The cycle of heat within the mantle is the driving force for plate tectonics. The Earth's crust is divided into oceanic, which is comparatively thin, dense, and young compared to a thick, lighter, and much older continental crust. The varying thickness and composition of the outer crust are further subdivided into 13 major plates, called the lithosphere plates, which move on top of the mantle's rather plastic, molten asthenosphere. The first phase of the convection cycle begins with rapid mantle convection, which leads to the breakup of supercontinents. The movement of supercontinents compresses the ocean basins, which allow the sea levels to rise. The seas move on to land, during which there is an increase in volcanic activity and volcanism flooding, which increases carbon dioxide in the Earth's atmosphere, which in turn creates a greenhouse effect and induces warmer conditions worldwide. The second phase of continental cycle is when there is low mantle convection. Low mantle convection results in the formation of supercontinents. The sea retreats from land and ocean basins are widened. The subsequent decrease of volcanic activity results in an icehouse effect, causing global temperatures to lower and possible glaciations. The fluctuation of magma, which drives convection, is caused by heat flow within the Earth's interior. Scientists know more about the far reaches of the universe than they do about the vast interiors of Earth. By contrast, even the deepest drill holes have only reached a few miles. The Earth is mostly mantle, which is composed of primitive rock and has not changed significantly since the early history of Earth. The mantle is in a semi-solid or plastic state, with the exception of the thin layer of partially melted rock between 70 and 150 miles below the Earth's surface. Rifting of continents, or the breaking up of supercontinents, occurred when the thick lithosphere transforms into a thin layer, driven by the heat being dissipated from the mantle. The heat eventually cracks the crust, forcing the continents to split and drift apart, and it is driven by convection and heat loops. A rift is the beginning of a complete continental breakup. Failed rifts, those which did not succeed in complete continental rifts, can be seen today. Plates are continually in formation and destruction. Human existence has not been around long enough to witness an entire cycle of possible plate movements. Plate tectonic activities result in the formation of mountain ranges and creates many oil, gas, and mineral deposits. Without plate tectonics, our planet would be static and lifeless. The process of plate tectonics is responsible for recycling water, carbon, and nitrogen, thus creating an environment that is conducive to life.